Hi everyone, welcome back to ANR Academy. Today we are going to discuss number of antisymmetric relations from a given set A to itself. The formula to find number of antisymmetric relations 2 power n multiplied by 3 power n square minus n divided by 2. Before going to discuss number of antisymmetric relations, let us discuss about first what is antisymmetric relation. See the definition of antisymmetric relation. A relation is said to be antisymmetric if x comma y belongs to R implies y comma x also belongs to R only if x equal to y. You know the definition of symmetric relation, that is x comma y belongs to R implies y comma x also belongs to R. But antisymmetric, for which an additional condition, that is only if x equal to y, then the relation is known as antisymmetric. That is here, suppose for example A is a set having entries 1, 2, 3. Let us discuss different relations based on the set capital A. Suppose that R1 is a relation, it has entries 1, 2, 1, 1 and 2, 1. Different relations first I am going to write and then check whether it is antisymmetric or not. Second example, 1, 1, 2, 2 and 1, 2. Another relation I am going to write 3, 3, 2, 1. Another example, suppose that 1, 1, 3, 2. Observe all the four relations whether they are antisymmetric or not. The definition is here clearly, if x equal to y only x comma y belongs to R implies y comma x belongs to R. X equal to y, the possibilities here 1, 1, 2, 2, 3, 3. So clearly 1, 1, 2, 2, 3, 3, they are itself satisfies the condition x comma y belongs to R implies y comma x belongs to R. Next, suppose if you have 1, 2, 1, 2 in which 1 not equal to 2. If both the coordinates are same, implies its reverse, that is its symmetric pair also belongs to that relation. Otherwise, you cannot write its symmetric pair. Here, x not equal to 2. 1, 2 and 2, 1, both you have. 1, 2 implies 2, 1 also belongs to that relation only when x equal to y. But here x not equal to y, so that it is not antisymmetric. Listen carefully. If you select one of the pairs belongs to that relation, its symmetric pair, that is 2, 1 also belongs to that relation only when both the coordinates are same. But here both the coordinates x comma y are different, so that it is not antisymmetric. So if 1, 2 present on the relation, then 2, 1 does not present in that relation. If 1 comma 1 present in that, obviously its reverse, again 1 comma 1 belongs to that relation. So the possibility to write its symmetric pair only when both the coordinates are same. So here it is clearly antisymmetric. But it is symmetric, remember. Why? Because 1 comma 2, 2 comma 1, 1 comma 1, its reverse 1 comma 1. So it is symmetric but not antisymmetric. First one, it is not antisymmetric. It is just symmetric. Next, see the second relation. If x equal to y, x comma y and y comma x belongs to that relation. That is the definition. Here 1 comma 1 belongs to the relation, implies it's a symmetric pair. On reversing it, again 1 comma 1 belongs to that pair. And the possibility only when both are same. So 1 comma 1, 2 comma 2, obviously they are in that antisymmetric relation. And then cross check here, third pair 1 comma 2 we have. Only 1 comma 2 is there. So it is antisymmetric. Why? Because if 2 comma 1 present in that pair, then it is not antisymmetric, remember. Only when both the coordinates are same, then only there is a chance to write its symmetric pair. There is no symmetric pair in the relation. Why? Because they are unequal. So it is antisymmetric. Just remember, there is a possibility to write its symmetric pair only when both the coordinates are same. Yes, here 3 comma 3, obviously that present in the relation. 2 comma 1, yes, its symmetric pair not present in that relation. Why? Because they are unequal. So it is antisymmetric. Next, 1 comma 1, 3 comma 2. 1 comma 1, obviously since the coordinates are same, that must present in that relation. 3 comma 2, only 3 comma 2 is there. There is no 2 comma 3. Why? Because x comma y, they are unequal here, so that there is no 2 comma 3. Only when equal, then only you have to write in the reverse manner. So it is clearly antisymmetric. These are different examples for antisymmetric relation. Now let us move how to find total number of antisymmetric relations from a given set A to itself. Yes. See here, we know that every subset of A cross A is called a relation, and A cross A contain set of all order pairs. Suppose A is a set having entries 1, 2, 3 and so on n. That is cardinality of the set, suppose that small n. Then A cross A that contains set of all order pairs 1 comma 1, 1 comma 2 and so on 1 comma n. Next 2 comma 1, 2 comma 2 and so on 2 comma n. In the same way n comma 1 and so on n comma n. Total, the cardinality, total number of entries in A cross A, that is n into n, n square. You know this. Here this matrix indicates set of all order pairs which are present in A cross A. 1 comma 1, 1 comma 2, 1 comma 3 and so on 1 comma n, similarly up to n comma n. Total there are n square elements. So here I am going to write the total number of entries in A cross A first. we are going to check how many such relations are possible to satisfy that antisymmetric condition. Total how many you have? Total pairs n square, in which how many diagonals are there? Diagonal entries. Total elements. Next I am going to write diagonal elements. Diagonal elements are n. See the matrix. These are all diagonal entries, principal diagonal entries. Next, non-diagonal or off-diagonal elements. Here, off-diagonal elements are remaining all, n square minus n. And off-diagonals are divided into two portions, upper half portion and lower half portion. Here upper half contains n square minus n by 2, lower half contains n square minus 1, n square minus n divided by 2 elements. Why? Because they are equally distributed. So in which upper half n square minus n divided by 2 and lower half n square minus n divided by 2. That is very clear. Now, see how to find number of antisymmetric relations from a given set capital A to A itself. We know that every subset of A cross A is called a relation. So, the total possibilities, number of antisymmetric relations, the total possibilities I am going to divide into two works. In how many ways we can select principal diagonal elements, and the second work, in how many ways we can select off diagonal elements. After writing these two, you have to multiply this, then only the entire work will complete. That gives the result, number of antisymmetric relations from A to A. Yes, let us see. By the definition, by default, you can select any one of these diagonal entries in the antisymmetric relation. You may select 1, 1, 2, 2, 3, 3 or n, n. So, the number of ways selecting diagonal elements. Suppose if I select 1, 1, you may select or you may not select. How many chances are there? 2 chances. We are going to discuss only about the diagonal elements. The possibility to take order pair 1, 1, you may select or you may not select. See, here in R4 you have 1, 1, but in R3 there is no 1, 1. So, by observing the relations, 1, 1 may be present or may not be present. So, how many chances are there? Just 2 chances are there. The same applicable for each and every element which is present in the principal diagonal. So that 1, 1 having 2 chances, 2, 2 that has 2 chances. In the same way, last diagonal element n cross n also having 2 chances. So that it can be expressed as 2 to the power of n. Let us discuss about non-diagonal entries. There are totally n square minus n non-diagonals are there, and upper half n square minus n by 2, lower half n square minus n divided by 2. Yes. See these examples. If you select one of the pairs, for example, if you select off diagonal entry 2 comma 1 1 comma 2. If you choose a pair, symmetric pair 1 comma 2 and 2 comma 1, let us discuss the possibilities. What I am saying here, we are going to choose pair of symmetric order pairs which are symmetric, that we are going to observe on 4 relations. See, these are antisymmetric. This is not antisymmetric. This one R2, R3, R4 are antisymmetric. Here just 1 comma 2 may be present, or 2 comma 1 may be present, or both cannot present. If you select the pair, symmetric pair 1 comma 2 and 2 comma 1, consider this one. How many chances for this? Maybe 1 comma 2 present in that, or 2 comma 1 present in that. Both doesn't present. Both not possible. 1 comma 2 from lower half, 2 comma 1 from upper half. Both cannot choose. Why? Because if you choose both of them, then it is not antisymmetric. So both impossible, and neither of these two. Without 1 comma 2, 2 comma 1 also you can frame antisymmetric relations. So maybe both present, neither of these two. This is another possibility. So this is the possibility number 1, 2 and 3. Total how many possibilities are there? 3 possibilities for pair of symmetric non-diagonal elements, remember. Yes. Here the second work, if you observe, how can we select non-diagonal elements? That is the work. Non-diagonal pairs, total there are n square minus n, and from which we are going to observe symmetric pair. Symmetric pair means these two, one is from lower half and the other from upper half, you have to select. So how many symmetric pairs are there? N square minus n divided by 2. We are going to choose 2 pairs due to symmetry. So total n square minus n divided by 2 symmetric pairs are there. And if you observe these two, maybe this non-diagonal entry may be present from lower half, may be present from upper half, or both does not exist, both does not present in the relation. See here, presence of both, that is impossible. Maybe one pair from lower half and another pair from upper half, or otherwise we can't choose the pair. So total there are 3 possibilities are there, so that for each symmetric pair the chances I am going to write. Total there are n square minus n by 2 symmetric pairs in off diagonals, in off diagonal entries, and in which the selection of symmetric pair, the chances are 3. First one, 3 chances. If you choose these two, 3 comma 1, we are going to discuss about 3 comma 1, 1 comma 3. Maybe 3 comma 1 present in the relation, or 1 comma 3 present in the relation, both does not present, right? So here maybe only one from lower half, only one from upper half, the possibilities. And the third possibility, without these two, also we can frame antisymmetric relations. See here, there is no 1 comma 3, 3 comma 1, but the relations are antisymmetric. So that, but both does not present. Without 2, with only from 1, that is only one from upper half, only one from lower half, and without the 2. Total there are 3 chances. So here for each pair there are 3 chances. Total how many are they? They are n square minus n by 2, remember. Therefore here you have to from non-diagonals we are going to choose non-diagonal symmetric. So 3 power n square minus n divided by 2. So 2 power n multiplied by 3 power n square minus n divided by 2 is the formula to find number of anti-symmetric relations from a set capital A to itself. I hope you have understood everything. The students, those who are watching my videos, please subscribe the channel and please share different types of videos to your friends and family members, and those who need, they utilize the videos. Thank you so much, and don't forget to like, share and comment.